Okay, so we've got our synthesizer, and we could control it with a MIDI controller, something like this. But while this kind of interface is good for some things, like playing a 12-tone equal temperament scale, it limits us too. So there's no reason that a synthesizer needs a control mechanism like this. It doesn't need this kind of interface for any reason other than legacy. So sticking to these traditional interfaces kind of keep us locked in a certain relationship with the instrument, and it shields us from new experiences, new creative possibilities for interacting with our synthesizer. What if, instead of using a regular keyboard to control our synthesizer, what if we could plug in a variety of inputs? We could choose our own way of controlling the synthesizer. We can build a custom controller. So to do that, we're going to use one of these, an Arduino microcontroller, and we're going to use it to connect a variety of sensors and control interface mechanisms to communicate with the outside world, with us and sort of the world around us, to use a bunch of kind of really interesting and different ways to control our synthesizer. So we're going to come up with something that's much more unique and much more personal to our own synthesizers that we've been creating. The Arduino is an open source electronics platform. So it's something that blends very simple microcontroller hardware and software together. So an Arduino board can read inputs, so things like buttons or sensors or anything like that, and turn them into outputs, so controlling things like synthesizers or lights or motors or even things on the internet. Now you might be thinking at this point, like microcontrollers and circuit boards, I don't know anything about that. Don't worry, this isn't, kind of hard electronics. In fact, actually the Arduino, this, was specifically designed with beginners in mind. Okay, it was actually designed for graphics designers and architects and musicians and hobbyists. It's used by them as much as it is by kind of computing experts. So the Arduino actually offers us a really, really lovely little simple platform to try things out and kind of learn some very basic electronics. So the nice thing is it's simple, it's cross-platform, and it's relatively cheap. It's easy to get started, and we're going to make some interesting things with it. Arduino comes in two parts. We have the hardware and we have the software. So the hardware is the microcontroller or MCU board. So it's a small computer running on a single integrated circuit. This is basically a tiny, tiny computer stripped back to all of the essentials. So we call this the Arduino board. Now there's a few different styles of Arduino board. Some look like this, and some you can sew into clothing, or some, do very different kind of things. They all work in basically the same way. So today I'm going to be using an Arduino Uno, and let's have a little look at that. So this is our Arduino board. Let's have a little look around and kind of figure out what some of these things are and how we'll be using them. So the first thing, this long chip in the middle of the board, that's the 80 mega microcontroller. So that's the heart of your board. That's what's doing all of the kind of heavy lifting, so to speak. Everything else is kind of attached to that and communicating with that. So the first thing you might notice is here on the upper left side, we've got this USB port. Okay, now that's used mainly for powering up the board and uploading what we call sketches to the board, so telling the board what to do. And it will also allow us to communicate between our computer and our Arduino via serial, and we'll get into that in another video another time. If you're not powering the board by USB, then we have a power port on the bottom left hand corner of the Arduino. And that can be used to power the Arduino using like a little 9-volt battery or something. So this thing is really small and it's portable, and you can use it for things like installations or things where you don't always want it connected up to a computer. Along the top and the bottom edge of the Arduino, we have pin ports. So these pins are going to be the way that we communicate things into or out of our Arduino. So along the top row we have digital pins, and along the bottom row we have analog pins, and we also have in the bottom middle section we have the power section of the board. So the important things to note here is that we have options for powering elements at 3 or 5 volts, and then we also have some ground pins, and we'll get to those in a little bit. So that's the Arduino board. The other side of the Arduino platform is the software. Now the software is how we're going to program the board, how we're going to tell the board what to do and how to behave. So the software that we use is the Arduino Software IDE, so the Integrated Development Environment, IDE. And before we get started, just make sure that you have the Arduino software installed or on your computer. There's two versions. You can either use the standalone software client that you download from the Arduino website, or you can go to create.arduino.cc and you can use the web version, which looks a little bit like this. And you can edit your Arduino code and upload it to your board straight from your web browser. So let's get started with our first Arduino project. So we're going to start by opening a new sketch. And in Arduino, the programs that we write in the Arduino software, the IDE, are called sketches. And we save these as .ini files. So if you see those floating around on your computer, it's the Arduino file that you've created. So we're going to open a new IDE sketch, a blank sketch, and this is what we get. We get a kind of pre-populated message with two areas, void setup and void loop. Now before we get into that, we just need to do two little checks. First of all, if you just plug your Arduino in via USB and plug it into your computer, we just need to check that the Arduino is seeing it. So what you're going to do is, on this top toolbar, you're going to go to Tools, you're going to scroll down, and in Board and Port, you're just going to check that the Arduino Genuino Uno is selected on both, okay? And if that's the case, you should get something like this at the bottom. And that's just to make sure that the Arduino knows to talk to this computer and this IDE. So here is the IDE, the environment that we're going to work in. Now we've got some in the top toolbar. This is where we're going to save and open patches. It's also where we're going to verify and upload our sketches onto our board. And then at the bottom we have a little console window. So this area is where it's going to tell us if we've got any error messages or anything like that. So it's a good idea to keep an eye on that. Now, when you start a new sketch, you get these voids. So a void setup and a void loop. Now, these void functions, this is the structure of the sketch, and they tell us when things are going to happen. So in void setup, like you might guess, this is the setup of our code. So the block between this brace, or these braces, so this section here, anything within these braces is going to run once at the start when the patch first loads, or when on the board, when the board powers up, or when we reset it. So we can put code in this section, in the void setup, to initialize and set up the board, to kind of get the board ready. Now, in the void loop section, anything that goes in this block of code, this is just going to loop continuously. And it's going to do that for as long as we leave the Arduino board powered on, really. So what we're going to do is we're going to set up some code, initialize the board, and then we're just going to continuously loop through that void loop section to run our code continuously. So our first patch that we're going to make, our first sketch, we're just going to make a very simple blinking LED. Now to do that, we're going to have to just write some simple code. First thing we need to do is define where we're going to plug an LED into this board. And then we're going to use the loop, void loop section to structure turning the LED on and off, because that's what a blink is, right? It's the LED is off, then it's on, then it's off, then it's on. So we're going to use that loop mechanism, that loop structure, to tell our LED to do that. Okay, let's get started writing our sketch. Now, the first thing to know is that in the Arduino IDE, the way that we're going to write comments is with this / comment, okay? So now I could give maybe the title of our sketch. That's a good thing, right? So let's play with our, remember Hello World, the that first step in a programming language. We're basically going to do the equivalent of a Hello World script, but in Arduino. So instead of Hello World, we're not going to print Hello World, we're going to do hello blinking light. That's what we're going to work on now. We're going to make a blinking light. Now, one of the nice things about the Arduino is that before we get into doing any hardware patching, so using kind of LEDs and buttons and anything like that, patching out to a breadboard, the Arduino actually has a built-in LED ready-made into it, and it's in a certain place. Okay, so it has a location. It's in pin 13. Now, what we need to do is we need to tell our Arduino Sketch to know that when we talk about an LED in our sketch, we're talking about pin 13. We're talking about a location. We're pointing our sketch to the right place to find our LED. So first line of code that I'm going to write is, notice that I'm not going to put it in the void setup. I'm going to put it just above. We'll talk about that in a second. But this is going to be int LED pin equals 13. Now, let's talk about what's going on there. What I'm doing is I'm defining a pin as 13. So int, that's the data type. So we're saying that this thing, this line, this is an integer number. Okay, so expect an integer int. Then the next thing, LED pin, that's a variable name. So we're going to call whatever this integer is, we're going to call it LED pin. Now the reason that we do that is because it's easier to refer to things by names than sort of trying to keep track of a whole load of numbers or locations or things like this. So now if I say, where's my LED pin? We know that it equals 13. Okay, so LED pin is the integer number 13. Now, don't worry if that doesn't make sense at the moment. You'll see why that's useful when we start to put it into context. So now, let's just good coding practice. We're going to define LED pin at pin 13 on Arduino board. Okay, so it's good to just keep track of to kind of write in comments as you go, just so that you know when you come back what you're doing and why you're doing something. So now we're going to use this setup void to tell the board where to find the pin. Okay, so what we're going to do is initialize digital pin. So this is the place where our LED might be plugged into, or in this case we know that it's at the location LED pin. So what we're going to say is when this board first switches on, it's going to run this little block in the void setup, and we're going to write pin mode, and then in brackets LED pin, comma, and then in all caps output. Okay, now remember how I said that the Arduino could read data in and put data out? Well, what we're doing now is we're saying that the pin that we're calling LED pin, so pin 13, so that's here on the board, this pin is an output. Okay, so we're not reading data in, we're putting data out. Pin 13 is an output. So that's all we need to set up with. Okay, really simple. Let's move on. Let's look at the loop. Okay, so when our board first switches on, it runs that little block of setup code. It learns what and where LED pin is, and then it moves on to the void loop section. So here it's just going to keep looping this all the time. So now what we're going to do is we're going to tell that pin what to do. We're going to do that with a function called DigitalWrite. So when you want to find out what a function does, one of the ways that you can do it is to find in reference. And what that's going to do is that's going to open up a browser that's going to open up here. It's going to tell you all about that function, okay, in the Arduino reference manual. And this is really, really helpful. Just like in Macs, where you use the help file lookup, that's how you're going to do it in Arduino. Just right click, find in reference. So DigitalWrite takes two arguments. The first thing that DigitalWrite needs to know is where are we writing something to? Where are we going to transmit this data? Well, we know that's going to LED pin. That's our location. Now, what do we want to write? Well, easily for us, an LED can be as simple as just saying high or low. Okay, high voltage or low voltage. High voltage, LED is on. Low voltage, LED is off. So what we're going to do is we're going to say send the high value to LED pin. That's all it would take to turn the LED on. Okay? Just one thing to note. Note that at the end of all of my lines, I have the semicolon. Okay, that's important because that's how the compiler is going to break this up into separate lines of code. It's like grammar when we write. Okay, we need to know where the full stop is. So we're going to use that semicolon there. Now, how does a blink work? Well, a blinking light comes on, and then it turns off, and then it comes on, and then it turns off. So we need to know how long in our loop this LED is going to stay on for. Because this is a loop, we can just do it really simply with a delay. So let's read through this sort of as it loops through. So the first thing we're going to do, at the top of this loop, we're going to turn our LED on. Okay, let's just get rid of that. Turn our LED on. Then, wait a second. In fact, actually, let's wait a tiny amount. Let's wait 100 milliseconds. So it's just going to be a very quick turn on. And then, I'm just going to copy this. We're going to do the same thing, but this time, we're going to write low. Okay? So, turn our LED on, send it a high voltage, wait 100 milliseconds, then turn the LED off, send it a low voltage. So this wouldn't work at this point because if we uploaded this to our sketch, it would loop straight back round. It needs to have some time to be switched off. So let's say delay 500 milliseconds. Okay? So, as we loop through now, turn our LED pin on, set it to a high voltage, wait 100 milliseconds, turn our LED pin off, send it a low voltage, wait 500 milliseconds, half a second, and then loop the whole thing again. That's it. That's our sketch. So what we're going to do is we're going to first of all verify it, and it's going to ask us to save our patch. So I'm just going to save that there. And then it's going to compile it. Okay, it's just going to check if there are any errors. Now at this point, I'm just going to plug in my Arduino. You want your Arduino plugged in via USB. And now all we have to do is hit upload. And it will run through, it will start uploading the sketch onto this board. And then, all being well, you should see, there we go. That is my pin 13 little test LED, and you can see it blinking away. The pin comes on for 100 milliseconds, and then turns off for 500 milliseconds. That's our first Arduino sketch. That's our hello blinking light. Good work. Now, it's all well and good using the Arduino's built-in LED for our first test, but we want to start plugging things in. So to do that, we are going to need a few things. First of all, we are going to take a small LED component. We're going to need a 220 ohm resistor. So you can tell, I can't get this in focus, you can tell this is the right one because the colors on the bands are red, red, brown, gold. You're going to need a couple of jumper cables, and you are going to need a breadboard or a prototyping board. Now, this is important because this makes it really, really easy for us to just plug things in without having to solder anything or solder any connections or do anything fiddly. It's basically just lots of tiny little holes that connect together to allow us to kind of plug things in. Now, if I turn over my breadboard, you can see that we have these metal bars going across. So this is what joins up anything connected, okay? So you'll see that we're divided into 2 columns, and then on the outer edges we have 2 really long bars that run the entire length of the breadboard. Now what that means is that essentially when I turn it around, we have a few sections. First of all, we have these 2 outer edges running down their side. Now anything connected here, 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 or here in these 2 small rows are going to patch together because they all join up onto the same metal conductor. In the middle, it's a bit different. In the middle, instead of running down, all of the rows run across like this. And we have another column of them here. So anything connected, for instance, to this hole, anything connected here will also connect to here, here, and here, because they all, on the back, join onto the same row. So, what we're going to do now is we're going to hook up our Arduino, and we are going to use our breadboard to very quickly patch in one of these LEDs. I've taken my breadboard and my Arduino and I've lined them up next to each other, and that's just going to make it easier for me to link over between the 2. Now the first thing we need is our resistor. That's this little thing here. Now we need a resistor of 220 ohms, and we can tell that this is the right one because the color coding on the bands goes red, red, brown, gold. So the first thing I'm going to do, I'm going to bend the legs of this, and then I'm going to take it and I'm going to line it up so this is going to move. We want to make sure that this is not connected like this, because if it was connected horizontally then they'd actually be connected on the same pins, remember. So we're going to connect this in just by popping the legs of the resistor in vertically. So I've put it in here and here. Now what that means is essentially these are on separate pins, so nothing is going to flow through. Then the next thing I want is my LED. Now you'll notice, if you look closely, the 2 legs of the LED, let me put something just behind so you can see it a bit clearer. The 2 legs of the LEDs are of different lengths. There is a short leg and a long leg. Now the short leg is what's called the cathode, which is positive, and the longer leg is the anode leg, which is negative. So I'm going to take the longer leg and I'm going to plug it in anywhere on the same row as that resistor. So what you can see here, hopefully I can make this a bit clearer, is I've got my resistor plugged in here, running to here, and then on the same row, just next to it, I've got the long leg of the LED plugged in, and then the short leg is plugged in over here. Now all I have to do to connect this up to the Arduino then is to take the pin from the short leg, the cathode of the LED, here we go, and I connect that up to ground. So let's just spin this around. We can go to ground here, and then the resistor is going to connect to, let's say, pin 3. Okay, so before we were using pin 13, which is the built-in LED here. That's this light. Now we're going to connect it up to pin 3, which means before we hook up our Arduino back to our computer, we're going to need to change the code. I've plugged in my Arduino. Now all I need to do in that code is change it from pin 13 to pin 3. And I'm going to upload my sketch, and sure enough, there we go. Now instead of our built-in LED flashing, we have this new LED, which is all connected up on the circuit board. Okay, now we want to try and patch something up that has a little bit more user interactivity. So what we're going to do now is we're going to use one of these, a little push button, and we're going to wire this up so that when we click the push button, the light turns on or off. So that will give us a little bit more kind of user interactivity. So the first thing we're going to do is we're going to patch this up. So this time I'm going to leave this blinking light set up pretty much as it is, but I'm going to unplug the ground from here, and I'm going to plug it in up here on the top of this strip that runs along the side. Okay, so I'm going to plug it into the blue strip, and that is going to act as the ground for a few other things this time. So I'm going to plug a new cable in. So I've also plugged that in next to this one, and that's going to go down to the ground pin on the Arduino. Okay, so they're still connected up, but now everything that runs down this side strip is also going to be connected to the ground. So next thing I will do is I will take my little push button, and you see the legs on the push button, there's 4 of them on the underside, and they will helpfully sort of bridge the gap that runs down the middle of the breadboard. So I can push that in, and now I have connection points here, 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 and here. So the only other component that we need now is another resistor. This time this is a, just grab a bit of paper, this is a 10k ohm resistor. So we can tell that because the colour on the bands runs brown, black, orange. Okay, so we'll take that and we will connect that to this leg of the button here, and that can run down. Remember that we run down or vertically to join onto different pins. Hopefully you can see that. I've got one leg of the resistor plugged in here, one leg of the resistor plugged in here on the same row as one of the push buttons. So then what I will do is I will take another jumper cable and I will connect this leg in the bottom corner. I'll connect that onto that ground row. Okay, so where we just plugged in that black cable that runs all the way down, so that would link this yellow cable here all the way up into the ground of the Arduino. Okay, so over here. Then I'm going to take this pin on this side and I'm going to connect this to pin 1. Okay, digital pin 1 of the Arduino. So we had the light, the LED connected on pin 3. Now this is plugged in on pin 1. Now the only other thing that we need is we need to power this button. So I'm going to plug in here, and I'm going to run that over to the 3.3 volt pin on the Arduino. So I've connected this button of the LED here, this button of the push button here, running all the way up to 3.3 volt. So now we need to update our sketch to reflect the changes that we've made in adding the pin button. So let's take a look at the original patch. So first of all, we set up our pins. Okay, so we said the LED pin was plugged into pin 3. Well, now we've got another one. Okay, we've got a button pin. So let's do this again. Let's add button pin, and we know that that is plugged into pin 1. Okay, so there's something else that we need to do. The button is either going to be on or off. Okay, it's either going to be pushed or not pushed. Now what we need to do is we need to start the patch by telling it kind of what the state of the button will be. So we're going to have a button state variable, and we're just going to start that off at 0. So now when we change the button, when we push the button, we can change the button state. Now what happened next? Well, we had the void set up. So this section of the patch only runs once when the script first runs. Okay, and we used that to initialize a digital pin for our LED. Now what we were doing was we were saying pin mode, so the LED pin, pin 3, is an output. Now we want to do the same thing but for our button. So we're going to do pin mode. This time it's going to be button pin. And this is not an input, this is not an output, this is an input. So we just declare that. Okay, so we've initialized our LED pin as an output and our button pin as an input. Easy. Okay, now this is where it gets not trickier, but this is where we have to add something else. Okay, so first of all, I'm just going to delete our existing blink. So remember, the void loop section runs continuously. Okay, it just loops through as we go. Now, what we're going to do here is we're going to read the state of the button value. Okay, so that button state variable that we set up at the top, that's going to equal what we read from that button. Okay, so button state is going to equal the value that we're reading from pin number 1. Okay, remember pin number 1, as we're setting here, is an input. Now, what we have here is we have to check whether the button's been pressed. Okay, now to do that in a void loop, we're going to have another kind of loop sort of nested inside. Now don't worry if you don't fully understand this at first, but it should make sense as you kind of play around with it and sort of start to figure things out. But what we're going to do is we're going to create what's known as an if loop. Now that's going to say, if this certain situation is true, if this certain situation occurs, then do this. If it doesn't occur, then do this other thing, do something else. Okay, so what we want is we want to check if the push button is pressed. So if button state equals, and we have to do 2 equals signs, otherwise it looks a lot like this where we're setting it. So 1 equal sign means you're setting a value, and 2 equal signs means you're checking if something is equal. So if the button state is high, that means if it's been pressed, we want to do something. Let's turn LED on. Now we'll make that happen in a minute, but let's just finish off our loop. If it doesn't happen, so another way of saying that is else, then we're going to turn LED off. And then when we close that loop, oh, we see that that's already closed there. Okay, so we just check that these pairs match up. Yeah, that all looks good. And this closes that. There we go. Okay, so now we can make this bit happen. So if that's the case, we're going to digital write. Where are we going to digital write to? Well, we're going to digital write to our LED pin, just like we did when we were writing the blinking. And we'll set it to high. And just the same to set it off. Turn it off. Okay, so let's verify our patch. Everything looks good, and we can upload it. Once we're done uploading, we should have, when I press the button, our LED lights up. Okay, so now we have a very, very simple method of interaction. Okay, I press this button, the Arduino processes that and learns what to do based on that state. Press the button, light comes on. Now, we could start to play around with this system. So what about, instead of just turning the light on, what if I were to take our blink system, so remember using the delay to say turn the light on, wait a second, turn the light off, wait a second, we could copy that in here. So now, instead of just turning the light on, I'm going to upload this. When I press the button, the LED should start blinking. And then stop when I take my finger off. So really, really quick, really simple ways of just sort of playing around with making this a little bit more dynamic, a little bit more interesting. The other thing to start doing, for instance, is we could start to include more LEDs. So at the moment I've just got one LED pin here and we're referencing this all the way throughout, but I could have another one and I could put that on pin 4. We'd have to call this then LED pin 2 so that it knows that there's a difference. And we could go through and just, refer to the right variable each time. So that would be LED pin 2, LED pin 2, LED pin 2, and so on. And we could chain up more LEDs and more resistors on the Arduino board. That's your kind of basic introduction to Arduino system. So we've looked at the whole Arduino framework from the IDE, the software side of things, up to the hardware, the Arduino board itself. In the next video, we're going to have a little think a bit more about this kind of communication between the Arduino board and your computer. So how can we use this? How can we use the control mechanisms that we've created here to control aspects of your max patch, of your synthesizer? We're going to do that with this. We're going to use the serial port, the USB port connection between your Arduino and your max patch. And we're going to get into some more interesting ways of controlling your system. Now, I should say, the nice thing about Arduino is that just as easy as it was to plug things in, we can switch out things for other things. So there's no reason that I have to use this little push button. I could use other things. So in my little box down here, I've got potentiometers, rotary switches, I've got LDRs, light sensitive diodes or photoresistors. You can have other kinds of sensors, flex sensors, bend sensors, all sorts of things. And it's really, really easy to switch them out and to kind of get your Arduino playing with all of these different things. If you want to try one of these other sensors or controllers, just quickly Google it. The Arduino community is really, really active. Everything is open source, so it's very easy to find out how to wire something up. All you need to do is just hop online and give it a little search. But I encourage you to play around with this and to see what you can come up with, and start to create some really interesting hardware systems using the Arduino. Enjoy!